Hello, welcome. This is a video on for the Unit 4 test preview, factoring out greatest common factors at the proficient level. And so we're starting with this problem of 84x cubed, 105x squared, 126x to the fifth. And we can start by looking at what are the prime numbers, because we're going to get the prime factors. So just as a reminder here, prime numbers are ones that have exactly two factors. And they include the numbers 2, 3, 5, 7, not 9, 11, 13, not 15, but 17, and so on. And so we're going to look at just the numbers. We'll talk about the variables here in just a second. So 84, we'll go 84, 105, 126. And I'm going to write this kind of like this. And then I'm going to ask myself, can I divide these numbers by 2? Well, 84 yes, and 126 yes, because they're both even, but 105 no. So then I go to the next. So I'd say no to 2. But 3, if you add the digits of a number, if it's divisible by 3, then the number will be divisible by 3 also. So 84 is 8 plus 4 is 12. 12 is divisible by 3, so is 84. 1 plus 0 plus 5 is 6, divisible by 3. 1 plus 2 is 3, and 3 plus 6 is 9, divisible by 3. All of these numbers are divisible by 3. And so if I want to see, I'm going to take that 84 and divide it by 3, and I would get 28. So 3 goes into 84 28 times, and 105 divided by 3 would be 35. And then 126 divided by 3. 126 divided by 3 is 42. So at this point, I'm going to just ask myself again, can I divide it 28 by 3? Well, 2 plus 8 is 10. 10 is not divisible by 3. And so I'm not going to try to divide. I want to divide them all by the same number. And so we're done with 3. We could divide it in, but we found all that we could. 5. Only if it ends in a 0 or a 5. So 35, yes, but 28, no. 48, 2, no. So I'm going to skip 5. 7. Well, I just happen to know that 28, 35, and 42 are all multiples of 7. So I'm going to go ahead and just put that. And then 7 goes into 28 4 times. 7 goes into 35 5 times. And 7 goes into 42 6 times. And so here at this point, I can then ask myself, with 4, 5, and 6, is there any prime numbers that will go into any of each of those? And the answer would be no. And so we're done, and we don't need to keep going. So the greatest common factor then is just 3 times 7 would be 21. And you can verify this, that 21 times 4 gives us the 84. 21 times 5 gives us the 105. And 21 times 6 gives us, let's try that again. 21 times 6 gives us the 126. Now, in terms of the variables, we're looking x cubed, x squared, and x to the fifth. X cubed, x squared, and x to the fifth. You don't always have to do this, but you can kind of just see here's x cubed has 3 x's, x squared has 2 x's, and x to the fifth has 5 x's multiplied together. So the factors that they would have in common are limited by the smallest amount, which would be the x squared. So that's what they have in common, is the x squared. So we know that the greatest common factor then is 21x squared. Our GCF is 21x squared. And so now we need to write this thing as a product. Having factored out the greatest common factor, we would write 21x squared times 4. And when we took out the x squared there, we were left with 1. So that's 4x. Just to keep track here, this was 84x cubed. 105x squared. 105x squared. And 126x to the fifth. 126x to the fifth. So then I'm going to put, I'm sorry, I've given too much information here. It's all they wanted us to do in this problem was to identify the greatest common factor. So I did not need to go further and write this as a product. Would have done had that instead of like a comma here, we had to have pluses or minuses, joining these as one term. But since that's not what we have, we just have 3 separate terms separated by a comma. We just needed to find the greatest common factor. So that's our answer for that.